Hello, calculus students. In this problem, we're going to analyze the function here, f. And when I say analyze, what I mean by that is we're going to determine the intervals of increase and decrease, any critical points if there's relative max and mins, as well as intervals of concavity and inflection points. And what's nice about this function is it holds a little surprise for us, as we'll soon see. So the first thing we're going to do is take the first derivative. Simple enough, that's a polynomial, so we can just use the power rule. And then the first derivative is equal to 0. Now remember, the reason we set this equal to 0 is we're looking for horizontal tangent lines. The first derivative gives us information about the slope of the tangent line to this curve, and the tangent line is horizontal when its slope is 0. So since f prime gives us information about the slope of the tangent line is 0 when the slope is the tangent line is horizontal when the slope is 0. Okay, so f prime is equal to 0. That implies that this expression here is equal to 0. And this we just factor out the GCF, the greatest common factor, which is 4x cubed, and we're left with the 5x minus 6. And by the factor theorem, that means that either 4x cubed is equal to 0, or 5x minus 6 is equal to 0, or both are equal to 0. Well, this one's easy to solve. That's just 0, and this one's simple to solve. Move the 6 over, divide by 5, so x is 6/5. Okay, now that we have these critical points, we are going to ask what is the sign, the SIGN, of this expression here, the first derivative. And I'm going to look at the factored expression. Because when we want to determine the sign of this expression, we're trying to determine the sign of f primed, and remember that when f primed is positive, that means that f is increasing. When f primed is negative, that means f is decreasing. So we'll build a little sign chart, then we'll test some points. X equals -1, we put that into this expression, we get a negative number and another negative number. Negative times negative is positive. We try x equals 1, positive, 5 minus 6 is negative, so positive times a negative is negative. Then we try 2, which is to the right of 6/5, which is a little bit more than 1. And we get a positive and a positive, and positive times positive gives us positive. So f prime is positive, negative, positive. That means that f is increasing, decreasing, increasing. And we could use the first derivative test then to determine that x equals 0 is a relative max because we're increasing then decreasing, and 6/5 is a relative min because we're decreasing then increasing. All right, now that we have the intervals of increase and decrease, we can go on to determine concavity. I'm going to do this a little more quickly, because it's the same type of analysis as we've seen here in the first derivative. We take the second derivative, we set the second derivative equal to 0, which implies that this expression is equal to 0. We factor it out, we determine the zeros, which are 0 and 9/10. 9/10 is a little bit less than 1. So then we do the sign chart analysis. The test points are x is -1. Well, that's positive. In fact, that's always positive. So we just have to determine that this term is negative. And then this is what's interesting here. You get to this point and you think that because where f double prime is equal to 0, we have an inflection point here. But look what happens. If we try the test point x is 1/2, that's positive, of course, but then we get 5 minus 9, which is negative. So positive times negative is negative. So we get two negatives in a row. So that means we're concave down on either side of 0, and that means 0 is not an inflection point. Then we have 9/10, which is less than 1, so we try 1 to the right of that, and if you plug in 1, you get 10 minus 9, which is positive. Positive times positive is positive. So f double prime is negative, negative, positive. That means that f is concave down, concave down, concave up. So the change of concavity comes in at 9/10. So this here is an inflection point, but x equals 0 is not an inflection point. There's no change in concavity. All right, now we can summarize our result here. We have the intervals of increase are negative infinity to 0, 6/5 to positive infinity. Our interval of decrease is 0 to 6/5. We're concave up from 9/10 to infinity, and we're concave down from -infinity to 0, and then from 0 to 9/10. Now, I did separate this interval. I can't go from -infinity to 9/10 because I do have to still pull out the 0 because this point even though it's not an inflection point, it's what we call a saddle point. And you can see right here, it looks like the graph really flattens out at 0. So I often think of a saddle point as if I was climbing the mountain here, I could take a rest and then either continue up the mountain, but in this case I would have to go down to this valley and then go up. So concave down on either side of x equals 0. All right, that's the full analysis. So good luck.